안녕하세요 여러분, 해리입니다. So in this video we're going to start learning continuous random variable. So if you're in SL students, if you're in SL, you don't have to watch the beginning of the video. You can just skip it to normal distribution, okay? For HO students, so let's start with continuous random variable. So for example, like height of people or weight of a weight of a student, those datas are continuous because, for example, we cannot make it as 65 kg, 66 kg, right? It can be 65 point something in between, right? So a very slight difference is still the difference, right? So for those data, we call it as continuous random variable. And for mathematical definition, so if a variable x is defined at the region A to B, and if the PDF, so we have already learned PDF, right? PDF of x, which is fx, so satisfies three conditions where fx is always greater or equal to 0, and 2, if we integrate fx from A to B, we have 1, and lastly, if we want to find the probability of x between C and D, then we can find it as integral from C to D fx dx, where C is greater or equal to A and D is less or equal to B. Okay, so if the PDF of x satisfies all these conditions, then we say x is continuous random variable. Okay, so for this one, well, it's good to know, good to know this definition, but the key thing here are these conditions. Okay, so and one important thing for continuous random variable, so you don't have to worry about less than or equal or less than, because it will not make any difference. This is because, so remember that if we want to find the probability, we're taking the integral, right? So that one, we can consider it as this, right? But in continuous random variable, that means integral from A to A, which is 0. And we can clearly get this from geometrically as well. So if you have a PDF like this, so let's say A to B, in this case, these should not be defined. So if we have A to B, that means this A is just a line. Does a line have an area? No, it's 0, right? That's why there is no difference with this. Okay, alright, so let's move on to mean and the variance. So if x is a continuous random variable and defined at A to B, then expectation will be A to B x times fx dx. Alright, so this, don't take it don't confuse with this. So remember the expectation value for discrete random variable. So we have sigma and we have x and we have probability, right? It's the same thing. So remember, in integration, I have explained that when we add up continuous data, sigma turns into integral, right? So it's the same. Sigma is the integral, the boundary, that's the boundary, x as being x. So this PDF is the same as PDF, okay? So it's exactly the same. That's it. So that's how we can find the expectation value. The variance is the same. So we have a property from this property, right? So this property holds for both continuous and discrete random variables. So that means variance, we can compute it as x squared expectation minus mean squared. And this, how do we calculate it? We can calculate it by x squared times fx dx. Okay, and the mean, we already have it, right? So that's it. That's how we can compute the expectation value and the variance. Okay. Then for standard deviation, the same. We just put square root on the variance. Then let's try an example. So for continuous random variable, you'll have PDF in piecewise functions all the time. So usually, let's say this. And 0 otherwise. So first we want to find A. Alright, I'll just write down the questions first. So find Alright, so for the first question, A, so note that if we add up the entire probability, it will always become 0. That means if we integrate from 0 to 0.5 ax dx, and if we integrate from 0.5 to 1, then this should be 1, right? So that's just a very simple integration. So that's a over 8, and that is half minus x, so negative half, minus half, so 1 over 8, minus half, so that should equal 1. That means a equals to 4. Okay, so not that difficult. Question B should be now, it's very simple. We want to find from 0.3 to 1, right? But you can see that 0.3 to 0.5 is here, and 0.5 to 1 is here. Then don't worry, just do integration with the correct boundary, with the correct function. So from 0.3 to 0.5, it should be defined as this function, right? So that means we integrate 4x. And then from 0.5 to 1, we are integrating this. So minus 0.5 to 1, 4x minus 1 dx. Okay, and for this, I will just leave it because it's just arithmetic. So now we move on to question C. So first, let's find the expectation value. So that's the function we have. So its expectation value is, again, how do we find it? We just multiply x to the probability density function, right? Then, and also from the entire region defined. So the region defined here is 0 to 1, but don't just do 0 to 1 because we have piecewise function, right? So from 0 to 0.5, we have x times 4x, right? Plus, from 0.5 to 1, we have x times negative 4x minus 1. Excuse me. One thing, so unless this is in paper 1, do not spend time to calculate this value. what you can do, you can actually use the function in your calculator. So you'll see an integral here. Okay, so that means from 0 to 0.5, 4x squared dx plus another integral 0.5 to 1 negative 4x times x minus 1 dx, and we have the value. Okay, so don't spend time on finding this, and it's the same for questions like this. Okay, so if you can use your calculator, please use it well, and then just put answer by GDC. Okay, so that's the mean, and let's find the variance. So variance, again, it's ex squared minus mean squared, and again it's the same for every distribution. So ex squared, we can find it by x squared. Alright, so let's do it one by one. So that's x squared from 0 to 0.5, 4x, right? And plus 0.5 to 1, x squared times negative 4 x minus 1 dx. So that means, again, use a calculator. So that one is just being squared, and that one is just being cubed, right? And that's what we have. And there should be a way to convert this into fraction, but I forgot the function. So yeah, we can just write it as 0.2917, so on. Okay, and if you use your yeah, so that's it. And right, so now we want to find the median. All right, how do we find the median? What's the definition of median? Again, median is the data at the middle, in the middle, right? Just in the middle. That means the probability must be 0.5, right? But we have a problem because we don't know where 0.5 is. So if this one, integrating this from 0 to 0.5, if it's greater than 0.5, if the probability is greater than 0.5, then the median will lie between 0 to 0.5. But if the integral from 0 to 0.5 of this is less than 0.5, that means the median would lie between here, right? So that means we have to find this value first, integral of 4x from 0 to 0.5. So to find the median, let's observe the value of this. And well, we don't really have to rely on the calculator because this is a very simple integral, right? So this is 1 over 8, right? Yeah. So 1 over 8 is 0.125. That means clearly the median must lie here, right? And note that that amount has 0.125. That means from 0.5 to the median, if we integrate this, we should have value of 0.5 minus 1/8. Why? Because this 1/8 is already from here. Then if we add up to, so if we find for 0.375 here, then that should be the median, okay? And how do we calculate it? Do we use integrate this and then write it as in like polynomial? Well, you can, but I'm not going to do that, and instead I'm going to use the function nsolve. So integral from 0.5 to negative 4 times x minus 1 dx would equal, should equal 0.375. Oh, sorry, and we are looking for the value m, so we put a comma and we put m. Then we have the median as 0.75. Okay, but please be careful about unsolved, especially when you have to find the roots of polynomials, because unsolved just gives you the first value. So for example, polynomial, if it has like multiple roots, then it will just give you the first root. So that it will not give you the entire answer. So for those questions, you should try to graph it out, okay? So that's median. And what about the mode? So mode means the highest probability, right? But for this question, I'm pretty sure they will not ask you for mode, but well, it's still possible. So for mode, it's better if you can sketch it, because basically you're looking for the maximum point of x. Why? Because what's probability density function? It yields a probability, right? So we have this, right? And if we just sketch it quickly, so that's half, that's 1. Then 4x, that means we are looking for the value until 2. Negative 4x minus 1, so we have the x-intercept 1 and the y-intercept as 4, so it's not including, so we have this and we have something like that. And clearly it's continuous, right? So where do you think the mode is? 0.5, obviously, right? That's it. Then what if we can't sketch it out? Then just look for the maximum point of this function, maximum point of this function, and evaluate the y value, the function value, and then choose the one that has the higher value. Then that should be the mode. Okay, so that's how we can compute mean, median, and mode, and the variance for continuous random variable. And now let's move on to a specific distribution called the normal distribution, and this is where SL students have to study as well. So normal distribution is the only continuous probability distribution that you learn in IB core. In IB HL stat option, you'll learn a lot more. So for continuous, you'll learn not a lot more actually. You just learn T distribution, but later, if you study statistics or probability in university, you'll learn a lot more like gamma distribution exponential, chi-squared, F distribution, and so on. So, well, statistics is very useful in real life, and it's very interesting as well, so it's good to know. But yeah, so anyway, for normal distribution, there's also some conditions too. So if the probability density function looks like this, where sigma is the standard deviation and mu is the mean, then x follows normal distribution. Okay? One thing, do we have to know this PDF? No, it's not in the syllabus. Then how do we find the probability? We use the calculator. So yeah, you will have to use calculator for almost every questions in normal distribution. You'll have to use your calculator. So as I said, the sigma and mu are the standard deviation and mean respectively. And in order to define the distribution, we need the two parameters, mean and the variance. So be careful, we have to put variance, not standard deviation. So we have to put standard deviation squared. So what kind of example can we do? So let's say a test score of a class follows normal distribution with mean 70 and SD 12. So find the probability of students having scores of 50 or below. All right, so let's look for this. So first we define the variable. So let's say x is a score, and x follows normal with mean 70 and SD 12, so that means 12 squared or 144. And we want to find the probability where the score is 50 or below. 50 or below. So this is what we have. Then what can we do? So we use the calculator. So menu 6, 5, and you will see normal on the top. And use cumulative, so you'll not use you rarely use PDF. So we go for cumulative. So it says lower bound like that, right? Note that for the calculator, the area is always from the left. Okay? So if you have a PDF, then we're always starting from the left to the right. So 50 should be on the right boundary, upper boundary. So the lower boundary, just leave it like that. That means negative infinity, almost negative infinity. And the upper bound is 50 here. So the mean is 70, and the standard deviation is 12. Then we have this probability, okay? So that's roughly 4.77%, okay? So simple, right? For normal distribution, I would really recommend you to just briefly sketch it, because for every normal normal distribution question, so that means the graph would look like this, right? I mean the PDF would look like this, so they always have the same graph. So it looks like this, and if you for those students who take physics, it looks like intensity graph, right? But anyway, so yeah, that's what it looks like, and this is where the mean is. Okay, so you can see that the mean, median, and mode for normal is always the same. They're always the same. Okay, that's one of the property of normal distribution. So the question just now, that's 70, right? And we were looking for the value of 50 or below. That means over here. Then we can kind of get a sense that so before we calculate the value, we can see that the value, the probability for this should be very low from the sketch. And then once we calculate it, we can kind of like verify it. So it makes sense, right? So we leave the answer. And also note that this is symmetrical. So that's 0.5 and that's 0.5. Okay? Yeah. Then it said it. So, well, for normal distribution, this is it. But you have to use another form of normal distribution called standard normal distribution. So what that means is that basically we're standardizing every random variables that can be modeled as normal distribution. And why are we doing this? Well, now in 21st century, we have the technology to simply integrate this, right? But back before, like in the past, when we did not have a proper calculator, mathematicians had to integrate this. And if you know about some integration, this is not easy to integrate, even for university students. So what we have, so for this one we have to use something called the power series and then approximate, but yeah, so it's very difficult to integrate this. So whenever mathematicians have to use the normal distribution, they have to integrate this all the time. And of course, that's very, very tedious. So what they did is that they thought of standardizing every continuous normal distribution variables into one form, so that they calculated those values and then made it as a table so that you can apply for every case. So standard normal distribution, in other words, we say it as z-score, and it's defined as x minus mu over sigma. So this x is the random variable for normal distribution. So z always follows normal with mean 0, standard deviation 1, and variance 1. And x, the normal distribution, it can be anything. Okay, so for example, let's say x1 follows normal with 3, 5 squared. Then for the mean of z, that means 3 minus 3 over 5, which is 0. And the standard deviation should be 3 plus 5. So 1 SD means 3, and then SD, 1 SD, right? So mu plus sigma, which is 8 minus 3 over 5, and that's still 1. So you can see that it always yields 0 and 1. And you can try for another variables like anything, this one. So it will be the same. The mean will be 0 and the standard deviation will be 1. Okay? So using this property, for every random variables that follow normal distributions, we can standardize it into a standard normal distribution. Okay? Then some may wonder, so, well, if we have a calculator, so for those who did not have a calculator, then yeah, we have to use standard normal distribution. But we already have a calculator, and why do we have to know standard normal distribution? We can use the standard normal distribution to do the reverse calculation. In other words, given the probability, you can find this specific x values, the value of the random distribution. So how? For example, x follows normal distribution with mu and sigma squared. So we don't know the mean and the variance. If probability of x less than or equal to 20 is 0.7, and if probability of x greater than 13 is 0.4, find the mu and sigma squared. So some questions like this you will have to use standard normal distribution. So before I talk about this directly, one thing to tell you is that I emphasize on the importance of sketching, right? It's gonna be very useful later because you will know what to integrate. So for example, 50 here, if we change this into z-score, that means the mean here will be 0, right? This 50 will simply become, so that's x value, right? So x, for every x value, you subtract the mean and you divide it by the standard deviation. So that means we have negative 5 over 3, right? And this one, we can actually use standard deviation, standard normal distribution to compute it as well. So just now, the answer for this problem is this, right? Then for this one, menu 6, 5, so cumulative again. So the lower bound, again, we always start from the left. So lower bound is negative infinity, and the upper bound is negative 5/3. Oops. Negative 5/3. And the mean is 0, standard deviation is 1 for standard normal, and if you compute it, it's exactly the same. Okay? So for this question, the sketching will be very, very important. So x, right? And since it's normal distribution, it will look like this. So we don't know the mean is, so let's put it as mu. Okay, 20 is above 0.7. So lower bound to 20 is above 0.5, right? That means this 20 must be somewhere here. And so x bigger than 13 is 0.4. That means so that's 0.7. So 0.4, that means that's where 13 is, right? So that's for this 0.4, and that's for 0.7, right? That means if we sketch this into standard normal, we now know the mean, right? Because no matter what the mean is, if we make it into standard normal, where it's x minus mu over sigma, it will be 0. And this 13 will be 13 minus mu over sigma, right? And this 20 will be 20 minus mu over sigma, right? That means for that one, it becomes z as 0.7. And for this one, so remember, we always calculate from the left, but it's the right, right? So what we can do is that we can use the idea of complement. So probability of x greater than 13 can be written as 1 minus probability of x less or equal to 13, right? So that one, we can just simply write it as 1 minus probability of z less or equal to 13 minus mu over sigma, and that will be 0.4. So we have these two. Then it makes sense, right? So two variables with two equations, but the problem is the equation doesn't look simple at all because it's not really an algebraic equation. So now we have to know something called the inverse normal. So that means in order to cancel this probability function, what we can do is that for this the equation 1, we can write it as 20 minus mu over sigma as the inverse phi of 0.7. And this is the notation for the inverse normal. And how do we find this? We can use the function here. So again, go to statistics, distribution, and you'll see inverse normal, right? And asks you to input the area. So area is 0.7, right? Area is the probability, and that's the the mean and the variance. Sorry, the standard deviation. So that's that value. So that means that equals to 0.5 to 4 and so on. Please note that for any questions that involves GDC, do not round it up in the middle of the step. So save the value. Okay? And let this be A. And for second equation, doing the same thing. So inverse normal 0.6, that's 0.253 dot dot dot, and again save this value as B. So let's say it's B. Then what? It's just simultaneous equation, right? So 20 minus mu equals to A times sigma, and 13 minus mu equals to B times sigma. And if we just subtract this by this, then we have 7 equals to A minus B sigma. So sigma will be 7 divided by A minus B, which is 7 divided by A minus B. So we have an exact value that has not been rounded up. So statistic, and then we can just let us see and compute for mu. So mu will be 20 minus A times sigma, right? So 20 minus A times C. That's it. So the mean will be 6. Okay. Oh yeah. So the standard deviation is very large, so it makes sense. So that's where 6.45 is, and then that's the values. So this is how we can find the mean and the variance. Okay, when they're not given. So that's it for normal distribution. And the thing is, well, to be honest, just with normal or just with Poisson, just with binomial distribution, they're not hard. The hard questions is when the question involves with multiple distributions. So in the same question, you have to use both normal and then apply this binomial distribution as well. And you will have a lot of questions like that. So I'll post them in the sample test. So please try the questions. Okay, so that's it for continuous random variable with normal distribution. So yeah, that's it. Bye.